Look at this conveyor belt. If you want to automatically count a precise number of identical packages moving past a proximity sensor and then stop the belt the exact moment you hit your target, you have a classic automation challenge. To solve it, we are going to program a complete logic sequence in Siemens TIA Portal. In this comparison, we take the physical factory machinery on the left and translate its actions into the clean ladder logic schematic on the right. Here is how the physical hardware maps out. We need a central Siemens S7-1500 PLC, a start and stop button array, a proximity sensor to detect the items, and a belt motor contactor to drive the movement. On the software side, you need TIA Portal version 14 or higher installed to follow along. Before you even open a project, defining exactly what hardware you have and what software you are using prevents addressing errors and logic conflicts later in the sequence. Open a new project in TIA Portal and navigate straight to the PLC tag table. This interface is where we define our user input tags. We assign the start button to memory address I0.0, the stop button to I0.1, and the item sensor to I0.2. Next, we add the specific output tag required to drive the physical belt motor, naming it Q_belt motor and assigning it to address Q0.0. Because these are simple on or off physical devices, you must explicitly set the data type for all of these inputs and outputs to bool. Systematically defining your memory addresses here in the tag table makes writing the subsequent ladder logic vastly faster and removes the risk of assigning the wrong action to the wrong physical port. Now let's open Network 1 to begin building the basic motor control sequence. As this diagram demonstrates, we construct a standard latch circuit. The start input contact is placed to energize the belt motor output coil. To safely break that circuit, we insert the stop contact directly into the path in a normally closed configuration. This latching architecture ensures the motor continues running after a single, momentary button press. This is the baseline requirement before introducing any automated counting logic. Let's move down to Network 2. Find the instructions pane and drag a count up block, or CTU, onto the rung. TIA Portal will immediately prompt you to create a single instance data block. This is expected behavior. The PLC needs this dedicated space to store the live count data as the sequence runs. We map the item sensor tag directly to the count up pin and lock the value 10 into the preset value pin. To clear old data, we connect our start button tag to the reset pin. At this point, we have a major physical failure point to address. If a package stops and rests directly in front of the sensor, the PLC will read a continuous signal and trigger erratic false counts. We fix this by inserting a positive edge scan instruction directly before the counter's input. As you can see, this instruction chops a long, continuous sensor signal wave into a single momentary digital pulse. By utilizing edge detection, we convert a messy, unpredictable physical signal into a precise digital trigger, guaranteeing exactly one count per physical object. With the count secured, we look at the counter's Q output bit. This specific output only turns true when the count threshold reaches exactly 10. We need to connect this math back to the motor. Go back to the motor control circuit we built in Network 1. In this split view, you can see how we are building the final interlock. We take the active counter Q output from Network 2 and map it to a new normally closed contact, placing it in series to break the main circuit line in Network 1. This specific interlock is the critical bridge of the program, allowing the mathematical logic of the counter to safely halt the mechanical motor. Switch your environment into monitor mode so we can observe the live flow of logic in the fully completed program. We begin the sequence. Pressing the start button launches the motor circuit and simultaneously clears the existing counter data. As the physical items move past the sensor, the edge detection captures clean inputs. You can watch the active count steadily increase. Watch the flow right here. The count hits 10, the Q output fires, the interlock opens, and the motor output immediately drops safely to 0. For future system expansion, you can assign a memory word like MW10 to the current value output. That allows you to display the live count data on an external interface screen for the operator. Mastering this basic interplay between hardware inputs, counter data, and interlocking outputs forms the foundational architecture required for programming advanced automated manufacturing sequences.